Good morning, dear students. Today we'll start discussing about the flame photometry. So very important from the point of your examination. So in the flame photometry, the principle of flame photometry is the emission characteristics of a radiation by an element and the correlation of the emission intensity with respect to the concentration of that element. So you know that the atoms present in the salt solution is made to excite into different energy levels. Now, when it is get excited into different energy levels, it will come back to its original state, that is ground state, by emitting a certain frequency of radiation. So that frequency of radiation which is getting emitted when the excited element or an atom comes back into the ground state. So that intensity is called as an emission intensity. So the principle of flame photometry is to collect the emission intensities of various atoms present in an element and correlating the emission intensity with respect to the concentration of the element. Now, in the general reaction, when you look into general reaction, and let us consider a simple example of Mx. M is the metal and X is an halogen, where let us consider sodium chloride as an example. Sodium is the metal and chlorine is the X. Now, sodium chloride is being made in the aqueous solution. So, especially this is used for sodium chloride, sodium and potassium, estimation. Now, sodium chloride is made in the form of an aqueous solution, and it is slowly, when it is being made into an aqueous solution, it will slowly ionize and exist as Na plus and Cl minus in the solution. Now, this Na plus Cl minus solution or a paste of sodium chloride is aspirated into the flame to get excite these metal atoms present in sodium chloride. Now, when you aspirate it into the flame, the sodium chloride will convert into its gaseous form. Now the solid which is dissolved in liquid will entire the mass is converted into gaseous form. So you will get Mx in gaseous form. So sodium and chlorine will get excited. So the and it will separate soon when it is forms a gas. Gas is very free. The elements or even the atoms are becoming free in the gaseous state, and when it separates, the metal sodium in the gaseous form carries the positive charge and get excited into an higher energy levels. Now when this metal gets excited into higher energy levels, it will come back to its ground state by emitting a certain frequency. That frequency is nothing but h nu, by emitting a certain frequency of radiation. So that emitted frequency is called as an emission intensity. So this emission intensity corresponds to the number of atoms in the excited state. So the emission intensity is calculated with respect to the concentration of sodium chloride initially being taken, and a calibration graph is plotted with respect to the emission intensity as well as the concentration of sodium chloride or potassium chloride, etc. And from the unknown sample, the same procedure is repeated to get the emission intensity. And from that emission intensity, how much is the concentration of the sodium or potassium is being calculated. So this is the principle of general principle of flame photometry. So principle of flame photometry deals with the exciting an element or an atom into an various excited state, and when it is get excited, and it will come back to its ground state by emitting certain frequency of radiation. That frequency of radiation is called as an emitted frequency or emission intensity. So that emission intensity is being correlated with the concentration of the element or an atoms present during the excitation. Now, what is being done in this procedure? So in this procedure, a solution is being made, a standard solution or the different concentration of the sodium chloride, different concentrations of potassium chloride containing a metallic salts. As I said, sodium chloride is aspirated. Aspiration is the process of introducing this substance into the flame. So it is being aspirated into the flame. Now when it is being aspirated, or which is being sent inside the flame, so vapors of these elements will form in the flame. So immediately it will form in vapors which contains these metallic atoms. Now the electrons in the metallic atoms are then get excited. So it will get excited immediately into the ground, from the ground state. Let us say E1 is the ground state of these various atoms or elements, and it will get excited to higher energy state, let us say En may be anything, more than one, that is 2, 3, 4, etc. So the electrons in the various concentrations of the metallic salts are excited and into different excitation levels, and by making use of thermal energy of the flame, it will get excited to a higher energy state. From the higher energy states, these electrons will return to the ground state by emitting certain frequency of radiation. So the energy difference between the excited state as well as the ground state, energy difference between the any excited state, it may be more than the ground state, any number, and that energy difference of the ground energy state, that is nothing but the emitted frequency. So emission frequency or emitted frequency or emitted intensity, so this intensity corresponds to the number of atoms present in the present during the excitation. So that is the principle of the flame photometry. So procedure, what it consists of, this flame photometer. Flame photometer consists of a pressure regulator. So this pressure regulator is aspiration. During the aspiration, the vapors are being formed, and the paste of the sodium chloride or potassium chloride is sent with the pressure. So pressure regulator is to regulate the pressure, and the flow meter for the fuel gases. So the fuel gases will be sent in a nozzle frame so that the flow meter will maintain it. An atomizer for introducing these metal atoms into the flame. Burner for converting these solution into vapors form, and an optical systems to record the emitted intensity, and a photosensitive detector. This photosensitive detector is to record the emitted intensity when the electrons in metallic atoms will come back to its ground state by emitting certain frequency of radiation, and an output recorder which will convert this emitted frequency into a digital recordings, and a suitable filter is to synchronize the radiations into a monochromatic radiation. To synchronize the radiation, suitable filter will be used. It depends upon the metal which is to be detected. Is inserted between the flame and the lens, so that flame and the detector. So LPG, propane gas, is used as a fuel, and then oxygen is used as an oxidant to burn these metallic solution into vapor form. A combination of these two will give a temperature of almost 1900 degrees Celsius. So and LPG and an oxygen which will be sent in a nozzle flame to produce a very high temperature of 1900 degrees Celsius. At this temperature, salts will get aspirated into the flame, and when it is get aspirated, vapors of the salts will be formed and they ionize in the gaseous state. Ionization takes place. Ionization, separation of metal with respect to halogen. Sodium will get separated, chlorine will get separated. Now sodium again immediately carries positive charge, and immediately it get excited into the various excitation levels from the ground state, and when it comes back, it will emit a radiation. That radiation will be recorded in the flame photometer. Now, whose analysis depends upon the flow rate of the fuel of the oxidant. rate of introduction of the sample in the droplet size. Now, in the sample containing an analyte, a paste of sodium chloride or a potassium chloride, is aspirated into the flame. So, and as I said, aspiration is the process of converting this into a very fine spherical droplet form of the salt, and the sample being introduced into the flame with the help of an atomizer. So atomizer is a unit way it will control the introduction of these salt solution in the form of a spherical droplets into the flame. So into the flame through an atomizer. Now the radiation from the when it is being introduced, the metallic salt solution is introduced into the flame. Now the flame, with the help of the flame, the liquid state of the metal salt solution, it converts into a vapor form, and when it converts into vapor form, it will be ionized in the gaseous state. So when it gets ionized into gaseous state, it will excite into various excitation levels, and during coming back, it will emit a certain frequency of radiation. Now, when it emits radiation, that radiation from the resulting flame is collected. Various radiations are being corrected by the lens. Say concave lens is used to converge these radiation, and the filter is to synchronize the radiation which is coming from the lens and allowed to pass through an optical filter. So once it synchronizes the radiations, these radiations are corrected with the photocell detector. These photocell detectors will detect different intensities of these emitted radiation, and it will pass through the recorder will give you a value in terms of intensity. That intensity is correlated with the help of concentration of this sodium or potassium, which is aspirated into the flame. Now, flow diagram of a flame photometer. Now, this is the flow diagram of the flame photometer. You can see very clearly that the fuel is being sent into the nozzle. Air is also being sent to develop a temperature of almost 2000 degrees Celsius. Now the sample is placed in an atomizer, and which is connected to a pressure regulator compression pump, and this sample will be sucked from this very fine nozzle and introduced into the flame in the form of a small spherical droplets. Now that spherical droplets is generally in the form of aerosol. The aerosol, it will be converted in the form of a mist kind of aerosol. Now the mirror is being placed backside of the flame also to converge the radiation into the lens. The immediately after this, once it is getting inserted into the flame, the liquid state of sodium chloride, Na plus and Cl minus in the solution, is converted into vapors of gas. So it will form Na plus and Cl minus in the gaseous form. Now electrons in that will get excited into various energy levels immediately with the help of the flame. Now once it gets excited, it will come back to ground state by emitting a certain amount of radiations. So that amount of radiations will be converged to the lens. The slit will allow only the radiations of required intensities to pass through, and the filter is to converge the or synchronize the radiations. So this depends upon filter number, will depends upon the element which is to be detected, and which will be passed through photo detector, which will detect the different intensities of emitted radiations. So these radiations. Now, how the procedure is being performed during this process. Now, the procedure is, first you have to prepare a standard solution of sodium chloride or potassium chloride by transferring 2,4,6,8, 10 ml of sodium chloride into a different 50 ml volumetric flask from the billet, and all the solution is 2 cc to 10 cc solution of sodium chloride is filled with the distilled water to up to a mark, and the volumetric flasks are stoppered and shaken well to get the uniform concentration. Now these similar procedure is done with the further test solution also. And the test solution whose concentration of sodium or potassium needs to be detected is taken into a volumetric flask and also added with distilled water to make up to the mark and shaken well. Now instrument is switched on and the gas supply is also switched on, and air pressure is adjusted to almost 10 psi because it has to be sent in pressure using the pressure regulator knob, and sodium filter 589 nanometer. So sodium requires a 589 nanometer filter is inserted into the filter position. Now the capillary of the tube, which is being dipped into a cell containing this solution. The stream of air atomized as a fine mist draws up the liquid, and with the help of the pressure regulate the gas so that the color of the flame completely turns into blue. So it is to be very noted here, the sodium emits a very intense blue color radiation. So when you atomize, when you aspirate these sodium chloride in the form of spherical droplets, you should adjust the intense burner speed, the flame, in such a way that it should completely burns into very blue flame, and the photometer knob is adjusted to 0 by means of a zero control knob. Now 100 ppm of the sodium ion solutions is inserted into the flame, and reading is adjusted to 100. Now this procedure is repeated to confirm the accuracy of the calibration. Now once it is getting calibrated with the help of 100 ppm of sodium chloride solution, and the instrument is adjusted to first 0, then to 100, then the instrument is calibrated. So prepared sodium solutions of different concentration, that is 2 to 10 cc, are aspirated through the film one by one, including the test solution. Now you should keep in your mind that when you aspirate 2 cc to 10 cc of the sodium chloride solution into the flame, it should be ensured that each of the solution is getting completely burnt, in the sense completely excited, and the blue intense flame should occur. And the test solution, note down the corresponding reading with the help of a recorder, and you have to plot a graph of the flame photometer intensity. So that is, intensity is called as flame photometer intensity. The flame photometer intensity readings against the concentration of Na plus solution to get the calibration curve. So test solution is also being done with the similar procedure of aspirated into the flame, and when metal ions get excited, the emission intensity is recorded, flame photometer intensity is recorded for the test solution also. From the calibration curve, the concentration of sodium ions in the test solution is calculated. Now how does the observation and calculations? Concentration of standard Na plus solution, standard solution is 100 ppm. Now this 100 ppm is done for calibrating the instrument. Now after that you are aspirating 2 cc, 4 cc up to 10 cc of the solution. Now you have 5 different solutions, let us say 2, 4, 6, 8, 10, 10, 5 different concentration of sodium. Now volume of Na plus solution in 50 ml of volumetric flask, that is equal to VML. You have taken 2 cc, 4 cc, 6 cc, 8 cc and 10 cc. Now test solution whose concentration needs to be detected is also being aspirated into the flame. Now in the third column, what is the concentration of Na plus solution in ppm, how to calculate it? Then V into 100 divided by 50, that is 2 into 100 divided by 50. If you do, you will get so much of ppm of the solution. Now once you calculate the concentration, you have to record the flame photometer reading. Flame photometer reading against concentration of Na plus solution of 5 different concentration you have to plot to get the calibration curve. So once you get a calibration curve, test solution is also being done with the same procedure and is being aspirated into the flame. So you don't know the sodium or potassium ions present in the test solution. So test solution, it will give you flame photometer reading. From that reading you can extend a line to the x-axis to get the concentration of Na plus solution. So the graph looks like this. Flame photometer as like the graph of your colorimetric estimation. Now you have to plot a graph of a flame photometer reading, that is emission intensity, with respect to the concentration of Na plus in ppm. So when you plot a graph, it will give you a straight line passing through the origin, and you have to repeat the procedure for the test solution to get the flame photometer intensity for the test solution. And from the test solution value, you have to extend the line, you have to draw a line to the calibration curve, and that line you have to extend it to the x-axis to get the concentration of sodium in the test solution. So that is equal to so much of ppm. So result is the concentration of sodium in test solution is so much of ppm. So this is the simple way to calculate the concentration of especially sodium and potassium with the help of a flame photometer, which records the emission intensity of the particular element or an atom, and that emission intensity is correlated with respect to the concentration of sodium or potassium present in the aspirated solution. Thank you.